All right, guys, so let's talk a little bit more about this notion of text files on a computer. So files that basically contain just text, nothing else. So on a Linux system here, I'm on this system that I used to do some programming earlier in the semester. So let's go ahead and create a new text file. So again, remember on Linux, we do not need to have a .txt at the end or anything like that compared to like a Windows machine where you have to have that dot extension. On Unix systems, you don't need it. So I'm just going to hit return. Then if you do an ls-l, we should see that we have a new file created, and notice that it's 0 bytes in size. It's 0 bytes in size. Now let's edit it. Again, you can either use the Nano editor. I'm more of a VI person, but again, if we use Nano, for example, Nano new text file, and then there's add a character. I'm going to type the character A, and that's it. I'm not going to hit return or enter. I'm not going to do anything else. I'm just going to leave that as is, do a Control-O to write the file, and then Control-X to exit. And then if I do an ls-l, notice that it's actually grown to 2 bytes in size. Wait a minute though. I see this, and I see it has the character A in it. Now I know that text files store characters using what's called an ASCII code, the American Standard Code for Information Interchange, which is now part of the worldwide ISO Unicode standards that are out there. All right. But, and so basically every character, right, that's in a file will be represented by 8 bits. Actually, it only needs 7 bits. The ASCII codes are actually 7 bits, but we add on that bit at the front just to make it a full 8. But given the number of characters, right, because basically in the early days of computing, we only had, right, there's only so many characters and different codes that we needed and different sort of functions that we needed to have a code for. And so they found that a 7-bit code was fine. That worked well over this thing called RS-232 serial lines, where the first bit was used for parity. We won't get into that. That's my old communications electronics engineer coming out there. But basically, ASCII can be thought of as a 8-bit code, but you really only need 7 out of those 8 bits to cover all the codes that are in the ASCII encoding scheme. So basically, even if you have a text file, right? If I were to look at this file on the computer, it's saved on the hard drive as zeros and ones, right? So how do we represent an A, for example, right? And again, remember that for some reason there's 2 characters and they're not just 1, even though all I did was add an A. All right. So let's take a look at the contents of this, but let's have it printed out in binary instead. So I'm going to use this command called xxd binary and then do new text file. And so indeed, on line 0 in that file, right, the first line in the file, in line 0 of this text file, I have this 8-bit code and I have this 8-bit code. Ooh, so there's 2 codes in there. But again, from my standpoint, it looks like there's only 1, right? It's just the A character. Now, for some reason, it's saying A dot over here, but certainly there's no period in there. So that dot must mean something else. It's also yellow on this screen, right? So again, I can go look up, right, what 0110, 0001 is in the ASCII table, as well as what 00001010 is in the ASCII table. So let's go look it up. So again, remember, I only need the 7 bits out of this. Let's blow this up just a little bit more. I only need these 7 bits out of that code because again, ASCII can be handled by 7 bits, but again, it's stored as the full 8 because that's just what you do in computing. Everything's in multiples of 8, right? So we have 1100001. So let's go look this up in the ASCII code table. So I found one out here. The other way you can do is you can just just go to YouTube, or not YouTube, but Wikipedia. Wikipedia has a pretty decent ASCII chart. So it's even actually a little bit easier to use. So again, those on the first byte here, we have 0110. So we gotta go find the 110, right? There's the 110 column right there. And then the 0001 row, so 0001. And if I find the match here, you notice indeed it is a lowercase a. So 110 0001 is how A is stored in a text file. That's its 8-bit code because everything is stored in binary, zeros and ones. All right. So again, we're not representing, right? And for example, this might be a hexadecimal value A, or for example, if I did this. So if I, let's go ahead and edit this file. I'm going to add a 1 onto the end, right? A 1, Control-O, write it out, Control-X to exit, and then do an ls. and sorry, ls-l, you see it's now grown to 3. So we went from 0 bytes, added a single character, it grew to 2. Now I've added another character, right, and it grew to 3. Okay, so what's in there? Again, A1, and that's all I've typed in. Didn't type in, didn't hit the return key, didn't do nothing, right? All it does is just, all it has in there is an A1, okay? So again, this 1, in this case, right, is not the number 1. So it's not like a binary 1, which would be like this, right? So a true binary 1. What I'm doing is we're representing 1 as a character, as a printable character, not as a value. All right, we're encoding this because this is a text file. It's not a number that we're going to do a calculation on or whatever. We're simply storing we're simply storing 1 as a particular code. Well, let's do that same command. Let's do actually let's clear it to get the get things back up to the top here. So we're going to do the xxd command. There it is. Right, and now notice that I still have that A in there, right? Still have the A in there, the 1100001. So here's 110, and then, right, the 0001 row. So that's the lowercase a. Well, what's the next one? So again, only need those first 3 out of the first byte. So we got 011. So let's go there, 011, and then 1110. So 011, and then 0001. Indeed, there's the 1. So that's the ASCII code for the number 1, 1 being a printable text character, not as the value, right? Because obviously the binary value of 1 would be, if it was represented as 8 bits, would be that, but that's not what we're doing here, right? We're not treating it like it's a number, we're treating number 1 like it's a piece of text. And so that's how it's stored in the file, right? And again, we're storing it as a 011, 0001. So I go look that up, 011, and then find the 0001, and indeed that is the 1. But then what's this character? Like, what is this character? Notice we still got this dot over here, got shifted over after the 1 went in. But what is 00001010, right? A 0A. Well, let's go take a look at it. So we have a 0000, because again, we only need those 3 right there. And then 1010. Well, what is that? Well, notice that I'm not in like A's and B's and 1s and 2s and dollar signs, and I'm in this weird stuff over here, right? So what is this, right? So let's take a look. So again, if I scroll down to the 1010, so here's the 1010, it's an LF. 0000, 1010 is an LF. So 000010 is an LF. What does LF stand for? Line feed, line feed. So what that means is that when you add characters to a text file, the very first character that you add to that file, not only do you add the character, but hidden from you is also this thing called a line feed, a line feed. So thusly, that's why when you type, like you do a cat new text file, it prints out the contents of the file. But notice that the prompt comes back 1 line down. It comes back 1 line down. Okay, so why is that? Well, it's because you have that line feed in the file. So this dot is represented, don't know why they're using a dot here in this command, but this 0001, 1010, again, line them up, over here is the line feed. So you're automatically getting what's called a line feed in this file, okay? So take a look at this. So what if we did this? So let's go and nano the file. And then I'm gonna put my cursor here at the end and hit enter on my Windows machine, or return on your Mac. Control O to write it out, and then Control X to exit. Now let's do it this way first. Let's do an ls-l. Notice that it's still 4 bytes in size. That didn't really grow. And then let's do that xxdb. All right. So now notice, I'm sorry, it did grow. It went to 4. So here you have the A, the 1100001, 1100001. There's the A. 0011 0011 So here we have the 011 and then the 0001. So then there's the 1 in that file. And then now we have 0001010 000110. We have 2 of them, right? So whereas before we had 1 line feed, okay, 1 line feed before, now we have 2 line feeds. So what would happen if I then do a cat on the file? Notice I get the extra line now. Okay, so now I've got a line gap here because 1 line feed, and then you have another line feed. So after the cat file, right, runs through that file, right? So what the cat's going to do is it's going to scan through this file and print out every character. It's going to print out that character, read it off disk, and print out that character, print out that character, print out that character, right? So that's what we saw before, right? So if I, again, go back in here and I'm going to get rid of that line, that extra new line, okay? Then do a cat. So again, cat came in, read the A, right? So if I do the xxd-b new text file, so cat's going to come in, read that code off the disk, and say that's a printable A, right? It's then going to read that code off the disk and then print a 1 to your screen. But then I want the prompt. I don't want the prompt to show up right here. I want the prompt to be a line down. So again, you automatically get that line feed in there. So it reads the line feed, and then that way, when cat is done running, you get your prompt back, but on a line down. Okay. And then if I go in and modify the file, and let's go in and add, I'm using AI or VI this time, add my line feed of my own, right? And then now I'm going to do a cat. Now I get that extra line feed. Again, now I got 2 line feeds in there. So here's the A, it prints that out. Here's the 1, it prints that out. Here's the first line feed. So I go from here to here. And then here's the next line feed where it goes 1 more down, and then cat is done running, and then you get your prompt back, right? So that's what's going on inside of this file. And indeed, there's ASCII codes, right? The way that characters are encoded are using this coding scheme, but there's lots of other stuff that we don't see, right? So there's things like a line feed, a null character, all sorts of characters, right, that have nothing to do with, like letters and numbers and symbols and that kind of stuff, but simply have to do with other sort of, the things that you don't think about, but yet still have to be in there to represent stuff, right? So for example, there's got to be a code in there, right? So if you want a new line to appear in that file, right, then you got to have something that represents that there needs to be a line in that file. So like if you had something like this, right? So let's go ahead and delete this. So insert for score, and then hit return 7 years, right? And then I'm going to delete that line, right? So if I want to have these lines in the file, so there's ASCII code, ASCII code, ASCII code, ASCII code, and then notice here a space. I wonder what's going on there. So let's take a look, right? So let's go ahead and cat that now. So there's your 4 scores. Blank 7 years, and then let's use the xxd command. So again, if we look at line 1 in here, right, or bytes, I guess, 1, 2, 3, 4, 5, 6. So again, there's an F, I'm guessing, so a 0, what are we looking at here? So no, 110 was a 0110, so there's the F, right? So here's the F, O, U, R, right? 1, 2, 3, 4, right? That's how that data is stored on disk. Then you have this one right here. That's one of the 001s right here. And then with all zeros, and that's an SP. So that means a space, right? That's the ASCII code for the 8-bit, or in this case, 8 bits, but it's really, you only need 7 bits. That's the code for a space. And then after that, right, we have this 0111, 01110. Let's go take a look at that one. So what's that about, right? And my guess is, so the 111 and then 0001, right? And you have, so that's basically just continuing on. So now you're going to go, so here's the space, and so here's the S, right? And then here's byte 6. So you have 1, 0, 1, 2, 3, 4, 5, 6. So here's byte 6. So there's your C, and then the O, and then the R, and then the E, and then you're back to that 0000, 1010. So 0000, 1010. That's the line feed. So that's the line feed character. Next one, right? You have another line feed character. So one down, because there's really kind of 2 lines in there. And then you go down here to, here's your 7 for that E, right? Here's your E, your V, your E, your N. And there's that 000001000. There's your space, right? And again, so this really isn't showing the lines in the file. It's basically just showing the number of bytes. Looks like it prints out 1, 2, 3, 4, 5, 6 bytes at a time. So here's byte 0 in the file, byte 1, byte 2, byte 3, byte 4, right? So byte 0, byte 1, sorry, the 0, or the four, the 0, byte 1, byte 2, byte 3, byte 4, right? So that's kind of what's going on in a text file, how it encodes the characters that we see into a binary code that's stored on disk. And there are literally binary codes for everything. The original one in the computers in the United States, the first kind of encoding scheme for text was what was called the American Standard Code for Information Interchange, aka ASCII is how we say it. That's now part of a worldwide Unicode, and which basically now you have, right, you need more than 8 bits to represent all characters in the world, including all forms of text, English or otherwise, Russian Cyrillic, Chinese characters, all that sort of stuff, right? All of the world's languages and representation, right, is all have codes, right? So no matter what it is that you're typing in, whether it's English characters or Chinese symbols or or whatever it is, they are all now represented by codes, and that's all now part of what this thing called the worldwide Unicode. And so you obviously need more than just 8 bits. And so originally I believe that the Unicode was, I think, a 16-bit encoding. I don't remember what it is now. We can look that up. But anyway, a little bit of a peer into this notion of text files and ASCII, and just kind of like, how does a computer store text in a file, in a text file? All right, so I'll talk to you later. Bye.